This is Ms. Clark with Topic 3 Part 2, Solving Linear Systems. This is the third and final video for the Topic 3 series. So we're going to solve two ways. We're going to solve with elimination and we're going to solve with substitution. Now this first one that I'm looking at, I'm going to solve with elimination. And the main reason for that, other than elimination is generally a nicer way to solve, is that I've got all of my variables really nicely lined up. So I've got my x's in one column, my y's in one column, and my constants on the other side of the equal sign. So I've got both of my equations in standard form lined up really nicely. Now the goal again of elimination is that I want my variables to eliminate. So I want to create two coefficients with my equations such that I have opposite numbers. So if I have an 8 down here, I want to have a negative 8 up here. Or if I had a positive 12 down here, I would want a negative 12 up here. So I'm going to multiply my x variables just because I've already got an 8 and a 1, and all I have to do is multiply this top equation by 8 to give me opposite coefficients. So I'm going to multiply this top equation. I've got to distribute this 8 to all three of my terms, and then I'm going to rewrite the equations down below. So for my top equation, I'm going to have negative 8x minus 32y equals 192. And for my bottom equation, I'm going to have 8x minus 3y equals negative 17. I'm going to add these together. My 8 variables eliminate. That means I did the right thing. And I'm going to get negative 35y equals 175. Divide by negative 35. And I get y equals negative 5. I'm going to plug that y equals 5 into, I jumped up there for a second. I'm going to apply that y equals negative 5 into my first original equation, just because this x is going to be a little bit easier to solve for than this one, since I don't have to divide by 8. So that's going to be my original equation, so negative x minus 4, replacing that y with negative 5. It's going to be equal to 24. So I'm going to have negative x plus 20, because a negative times a negative is a positive, is equal to 24. Subtract 20 from both sides, I get negative x equals 4. Divide by negative 1 to get rid of that negative, and I get x equals negative 4. And so my final answer, or my solution to this set, is going to be the point negative 4 comma negative 5. Just a reminder, when we're solving a system, we're always going to want to find a point where those lines intersect. If they're parallel, there's not going to be a solution. If it's the same line, we're going to have infinitely many, but most of the time those lines are going to intersect at exactly one point, and that's going to be our solution. In this case, these lines intersect at the point negative 4, negative 5. All right, so I'm going to scoot down to problem number 2. Now I could technically solve this one pretty nicely with elimination, but I'm going to solve this with substitution because this is really best case scenario for substitution. Really, we want to use substitution when we have one or more of our equations solved for a single variable, and in this instance, since both of these are solved for y, this is going to be very easy to solve. So I've got y equals this one on top, and I have y equals this one on the bottom. But since I have y equals 2x minus 3, that means that this y up here also has to be equal to 2x minus 3, because we're finding the point where these lines are equal to each other. So that means I'm going to set this up. I'm going to say 2x minus 3 is equal to negative 2x plus 9. And then I'm going to solve for x. So I'm going to do plus 2x plus 2x plus 3 plus 3. And I'm going to get 4x equals 12, so x equals 3. And then I'm going to plug that into my bottom equation just so I don't have to deal with any negative signs, and I'm going to get y equals 2 times 3 minus 3 2 times 3 is 6. Y equals 3 also. So my answer is going to be the point 3, 3. Okay, and lastly, we have this equation. Now, I think a general rule of thumb is if it's not immediately set up for substitution, we should always try to solve with elimination, because in general, elimination is going to be the easiest, most efficient way to solve for an equation. We can kind of see here, if I wanted to solve with substitution, I'd probably try and get this y by itself, which means I would have to divide this whole equation by 7, and then I would get 11/7 as a fraction right here, and 3/7 as a fraction over here. Those are just not super nice numbers to work with. Oh, sorry. Alright, so now we're going to move to the last problem. And we can see that this problem isn't immediately set up for either substitution or elimination. And in cases like this, it's almost always the go-to to just use elimination. In general, elimination is going to be more efficient and easier to solve with. And so I'm going to have to simplify these equations and move things around. So I'm going to multiply this top one by 5, distribute that out first. I'm just going to start with this first equation and simplify it, and then I'll move to the last one. So I'm going to distribute the 5. That's going to give me 5x minus 15 plus 3y equals 10. I'm going to do plus 15 both sides, and I should get a final equation of 5x plus 3y equals 25. And then for this bottom one, I want to move this 11 to the other side, so I'm going to do plus 11 and plus 11, and then I want to move this 7y to the left, so I'm going to do minus 7y and minus 7y. These cancel, and I'm left with negative 3x minus 7y is equal to 11. This is my new system right here. Okay, so in this case, there isn't one particular whole number that I can multiply one equation to get the same or the opposite coefficients for my equations. So what I mean by that is there's no whole number that I can multiply 5 by to get to positive 3, and there's no whole number that I can multiply 3 by to get to positive 7. And so I'm going to have to multiply both of these equations by a number. And the numbers I'm going to choose, I'm going to multiply this top equation by positive 3, and I'm going to multiply this bottom equation by 5. You can see I sort of just use these front coefficients and then multiplied them by each other, and then I just made sure to keep one negative and one positive. And so if I multiply these out, my top equation becomes 15y plus, oh my goodness, becomes 15x plus 9y equals 75, and my bottom equation becomes minus 15x minus 35y equals 55. I'm going to add these together. These go away. This should have a y right here, so sorry. I'm going to have, this is going to be negative 26y. It's equal to 130. I'm going to divide by negative 26, and this is basically 26 times 10 divided by 2, so we have y equals negative 5. I'm going to plug that into one of my, well actually I could probably plug it into one of these since they're all nice and pretty. Maybe I'll plug into that one. Why not? We'll see. Let's just do that one. Take it. Yeah, okay, fine. We'll do that one. why not? So I've got 5x plus 3 times negative 5 equals 25. So 5x minus 15 equals 25. 5x is equal to 40. X is equal to 8. So I have my last final point, 8, 9.